Hi guys, let me welcome you all to another video. So in today's video, we're going to be doing transverse waves. So the scenario goes as follows. It says the diagram below represents a water wave that moves from left to right. So they've given you the direction of the wave's movement. The time between two consecutive crests is 0.5 seconds. So we can indicate that on the sketch. So here's your first crest, and there's the second crest that is consecutive to the first. So just the time between them is 0.5 seconds. So the first question says, what type of wave is a water wave? So when analyzing the sketch, you can see the direction of the particles. The H2O particles moves in an upward, downward movement, and the wave itself moves in a direction from left to right. So when the direction of the movement of the particles is perpendicular to the direction of the propagation of the wave, we say the wave is a transverse wave. So for the first question, the answer is transverse wave. So the second question says, write down the amplitude of the wave. So we know by definition that the amplitude is the maximum distance a particle can assume from the equilibrium position. So this here is your equilibrium position, and the maximum distance from the equilibrium is your amplitude. So this would be your amplitude, but they haven't directly given us the amplitude. However, they've given us the distance between the crest and the trough, which is 2.5, and from the equilibrium to the crest is half that distance. The amplitude would then be 1.25 meters, which is half of 2.5 meters. So the next question says, define the term wavelength. So to define wavelength, we have to bear two things in mind. The first thing is we have to look for two consecutive points. And the second would be to find two consecutive points that are in phase. So by definition, the wavelength is the length between two consecutive points that are in phase. So let's look for two consecutive points that are in phase. If you take A and C, you can see both of these points are on the equilibrium, but A leads to an upward disturbance in the wave, and C leads to a downward disturbance in the wave. So these 2 points, C is not in phase with A, but if you consider E, you can see that A and E are both on the equilibrium. A leads to an upward disturbance, and E also leads to an upward disturbance. So the wavelength is the total length between two consecutive points that are in phase. So the next question says, determine the wavelength of the wave. So we need to look for a distance between two consecutive points that are in phase. So we can already see that we have a clue here, 1.5 meters. So let's first identify two consecutive points that are in phase. If you consider point B and point F, we can see that both points are on the crest and they lead towards a downward disturbance. in the wave, and because this here is a trough, it means that the distance from PD to PF is the same. So that is 1,5. It means this here is 1,5 meters. So we can say that the wavelength is equals to 2 times the distance of PD, which is equals to 2 times 1,5, which is equals to 3 meters. So your wavelength lambda is equals to 3 meters. So the next question says name 2 points. Name 2 points on the wave form above that are in phase. So they want us to name 2 points. We saw earlier that point A and point E are in phase because they're both on the equilibrium and they lead to a rise in disturbance of the wave. And point B and point F are on the crests and they lead to a downward disturbance of the wave. So the 2 pairs of points in interest is points A and E, A and E, and points B and F, B, points B and F. And so the next question says calculate the time taken for 4 crests to move past a certain point on path of the wave. So in this question they want us to figure out how long it would take 4 crests to pass a fixed point. So if you go back, they tell us that the time between 2 consecutive crests is 0.5 seconds. So we can just note that the time between 2 consecutive crests is 0.5 seconds. So you will recall that B and F are points that are in phase, and because B and F are points in phase, it means that from B to F it is a complete cycle, and it means that 0.5 seconds is also the period of the wave, right? So in the given case, for the period of the wave, you always get two crests passing a fixed point in 0.5 seconds. I want you to bear that in mind. So for another full wave, from F to J is another 0.5 seconds. So this is another period, but now you have 1, 2, 3 crests. And if you were to extrapolate this graph, you will see that for another complete cycle, 0.5 seconds, you will have 1, 2, 3, 4 crests. So in other words, 4 crests this is the same as 3 periods. 3 times t. The time taken for 4 crests is the same as 3 periods, as we have seen, which is 3 times 0.5, which is equals to 1.5 seconds. And lastly, they want us to calculate the speed of the wave, so we can use the universal wave equation. That is, the velocity is equals to the wavelength divided by the period. And the wavelength is 3 divided by the period, which is 0.5, and this here is equals to 6 meters per second. Thanks guys for watching. See you in the next one.